To make our programs responsive and to feel like they're paying attention to us, they behave differently based on what we do. Move the mouse, press a button on the keyboard, the program changes its behavior. The key to taking different actions at different times is the if statement. The if statement is really nothing more than coming to a branch in a road and saying, based on certain conditions, do I go to the left or do I go to the right? We come across these kinds of things all the time. For example, if you go to an amusement park, roller coasters frequently have a sign like this to make sure that no one too short gets on the ride, because then it would be unsafe. Let's see how we can use this as the heart of an if statement. I'll sort of make this small and I'll compare it to a bunch of people who want to get on the ride. Who gets on and who doesn't? All we have to do is compare them against the height of that measuring stick. So let's look at the leftmost person. Is she tall enough? No, she's not. So we can put a little red dot over her head. All we're doing is saying, if this woman is taller than the upper line, she gets on, otherwise she doesn't. Let's look at the guy next to her. He's just a little bit taller than the line, so he gets to go on. The woman next to him, oh, she's just a smidgen over the line, which is good enough. So we can treat everyone this way, and we can treat each person as tall enough or not tall enough. True or false, yes or no. That's the essence of the kind of decision making we do in the computer. Just make a test that has the result true or false. Am I taller than the stick or not? That really is all you need to be able to do, and everything else comes from that. This matches the kind of thing like this picture where we have exactly two choices, left or right. And that's all there is to it. Let's look at a program that can use an if statement. Here's a little program that definitely is going to be able to use some help. Before we even look at the code, let's just run it and see what it does. It creates a window, and then the background color gets brighter and brighter and brighter red. And then finally it becomes super bright red, and the action stops and we're all done. What I'd really like this thing to do is when it gets to be super bright red, I'd like it to go back to black and make its way back up to red again, so it doesn't get stuck at super bright. Let's take a look at the code and see how to make that happen. The first three lines declare three variables, three integers, red, green, and blue val. And so those are going to obviously be the components of the color that I draw. Setup is nothing interesting, size and smooth. Draw itself is really nothing interesting. I call background using the current values of red, green, and blue val, and then I add 1 to red val. And of course, I could have said red val plus plus, but I wrote it this way. Because red val is a global, it remembers its value from one frame to the next. And so in this code, red val just gets brighter and brighter and brighter until it gets to 255. And then it becomes 256 and 257. And it just keeps going. It becomes 1,000, 10,000. But processing says anything bigger than 255 in a color is 255. And so the thing just clamps and it gets bright red and sticks there. What I really want to do is something like this comment. I want to say if red val becomes larger than 255, then make red val 0. So let's see how to actually write that in processing. To write this in processing, let's start with a natural kind of English description. If the value of red val is larger than 255, then set red val to 0. This describes what we want in English, and it's not that far from the way we write it in processing, but we do have to make some changes, and let's go ahead and do that. The first thing I'm going to do is to make a copy of this and take a look at the test, the stuff that comes after the if. The test is the value of red val is larger than 255, and I'm going to wrap that in parentheses. You may remember we use parentheses to also wrap up the list of arguments to a function. This is a different use of parentheses. There are only so many grouping characters on the keyboard. There's parentheses and square brackets and angle brackets and curly braces, and that kind of runs the list. So we're reusing parentheses here, but there's no chance of confusion because these are the parens that come after the if statement, and they wrap up the test. Now let's look at the test. The value of red val is larger than 255. Well, we know that the value of red val is simply red val itself. So let's get rid of the words the value of. So this means the same thing. If red val is larger than 255, and as you might expect, we don't write is larger than. We use the handy little symbol greater than. So this means the very same thing. If red val is greater than 255, then set red val to 0. Now we're going to make another little change. Notice the word to near the end. Well, what do we do in processing when we want to set a variable to have a given value? We use the equal sign, right? So let's go ahead and do that. Set red val equals 0. All right, we're getting there. There are a few little extraneous things we don't need here. We don't need the comma. It's useful in English, but it's not necessary for processing. Processing also doesn't need then or set, because they're redundant. It knows anything that comes after the closing parenthesis of the test is the thing that is to be done. Now, to turn this into an actual processing statement, all we have to do is stick a semicolon at the end. This line is the final result. This is processing talk for the first line. And the way we read the final line is, in English, almost exactly the way we would read the top line. We read it as, if red val is greater than 255, then set red val equals 0. So let's type exactly this line into our program and see how well it works. Let's type in the line we just saw. If red val greater than 255, red val equals 0. Now we'll run the program. And the red gets brighter and brighter and brighter. And when red gets to 255, bam, it goes back to 0. So the little test is working for us beautifully. If red val ever becomes larger than 255, it goes back to 0. And this will repeat forever. I'll just show you one little way of tightening this all up. Notice that I'm first adding 1 to red val, and then I'm testing its value. That's perfectly clear, and you can see it's running just great. But often people will use the shortcut, say red val plus plus. In fact, even better, we can take the shortcut and roll it into the if statement. And in this case, I will pre-increment. I'll use the plus plus first. So what this is telling processing is, well, we have an if statement. What are we going to do? We look at the test. First thing we do is we add 1 to red val. And now we proceed with things. And now we test it against 255. And if it's not larger than 255, it doesn't do whatever is here. But when the test becomes true, when the incremented value of red val is greater than 255, then red val gets put to 0. So tell you what, just to make it clear, we're not doing that. Let's take out that comment, and let's take out that comment. So now this is the program, and if I run this, it will run in exactly the same way. Red gets brighter, 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 and then drops back to 0. You will often see people writing things this way. So this gives you the idea of what's going on inside of an if statement. Let's take a closer look. We've just seen that an if statement lets us implement a two-way branch. We either go left or right based on the information we have. If red val is greater than 255, we set it to 0. Otherwise, well, we don't do anything. In our test, we use the greater than symbol to see if red val was greater than 255. As you might expect, there's a bunch of these tests. Let me show them to you. There's greater than, which we just used. And then there's this little thing, greater than or equal, which is the greater than sign immediately followed by the equal sign. There cannot be a space in there. And that will be true when this value is greater than or equal to the other. Suppose we ask, is A greater than or equal to 5? If A is 5, greater than or equal will succeed because A is equal to 5. Just as we have greater than, we have less than. And just as we have greater or equal, we have less or equal. And again, there can't be a space in here. Now here's the weird one. To test equality, to see if a variable has a particular value, for example, to see if A is exactly equal to 5, we use two equal signs. This screws up people in the beginning more than anything else. You need two equal signs. Why? Because we're already using one equal sign for assignment. We've already used up the equal sign. If you remember from earlier videos, I said people have been trying to get away from the equal sign as an assignment statement. We've used arrows, we've used all kinds of things. The equal sign persists, and this is the reason. We want to use the equal sign to mean equals, and we can't because we've already used it to mean assignment, and it can't mean both things. So equals uses two equal signs. I fully agree that this looks a little weird, and it's going to look weird, and it's going to feel a little strange, but keep it in mind. And then very quickly, it will become totally natural. And almost every language like processing does it this way. And so once you get this in your bones, you'll be good to go. Finally, there's not equals. And the way we say not in the computer is to use the exclamation point, which is sometimes pronounced bang. And so people will say this, bang equals. And again, there cannot be a space in there. Although this particular expression, you would say not equals. But if you were reading it out to someone and telling them what to type, you might say bang. So the key thing to remember here is that the equals has two equal signs, one after the other. In part 2 of this discussion, we'll see these tests in action.